So now we're going to look at another graph and find all the zeros. So again, we can't factor this one. So if we try to factor it by grouping, we take out the common factor. We have x minus 7, take out the common factor, which is 3, 5x minus 3. These are not the same. Okay, so we can't write this as x squared plus 3, x minus 7, and 5x minus 3. So do not do this. This is a big no-no. If you were to do that, you're not going to have x to the third anymore. You're going to have x to the fourth, and it's nowhere near what you need. So that doesn't work. So we're going to graph it and look at the graph. So if we look at this, here's our function, here's our graph. Okay, so it's crossing at two places, here and here. So we can use one of the zeros. So let's just use 1, which is, let's use that one. So x equals 1. And we got that from the calculator. So from the calculator or the graph. Okay, so use 1 for synthetic division. 1, negative 7, 15, negative 9. We're going to bring down the 1. 1 times 1 is 1. Add it, we get negative 6. Multiply it, add it, multiply it, add it. So now we have x squared minus 6x plus 9 equals 0. So now we can just factor it. Multiplies to 9, adds to negative 6. So we have x minus 3 and x minus 3. So if we set this equal to 0, we're going to get two of the same answer. So we have x equals 3 of multiplicity 2. So that means that 3 appears twice. And if we look at the graph, when you have a multiplicity, it looks like a parabola at that point. Okay, so it looks like a parabola. It means it goes to that value, it bounces off, and then it goes back. So let's kind of put all the stuff that we did together. So if we want to find the turning points, you have your maxes and your mins. So here's a turning point, and here's a turning point. If we put it in the calculator and do second trace and max and min, I'm just going to jump right to the answer. We get 1.67, comma 1.19, and we get 3, 0 for our other turning point. Okay, so turning points we just found, so I'll write them again. Okay, so we have 1.67, comma 1.19, and we also have 3, 0. Now we have our end behavior. So the end behavior, remember, since there's two ends, we have two end behaviors. Okay, so this first one, if we were to continue this line, the arrow would actually be in the third quadrant. So here, the x's are going to be negatives, and the y is also going to be negative. So my end behavior, I have my left side, x goes to negative infinity as y goes to negative infinity. And then for my right side, up here, I'm in the first quadrant, x and y are both positive. So for my right side, x approaches positive infinity as y approaches positive infinity. Increasing and decreasing, remember we go left to right, and we look at our x values of the end behavior and the turning points only. So first thing I'm doing on this graph, I'm increasing. So it's increasing from negative infinity to 1.67. Then it's decreasing from 1.67 to 3. And then it's increasing again from 3 to infinity. Now domain and range. Domain are the x values, range are the y values. So here my domain is going to be all real numbers. And my range for my y's is also going to be all real numbers. Okay, the reason being, if we look at this graph as this continues to go in the x direction, so as it continues to go left and right, it's going to touch every single x value at some point. So the ends are continuing to go in their directions forever, forever, forever. Since the left side is going towards negative infinity, it's going to keep getting more negative. As the right side is going towards positive infinity, it's getting more positive. So since we have a negative and a positive, it encompasses all of the x values. Same thing for the y's. The y is going to keep going down here, and it's going to keep going up here. So again, the end behaviors, you have a negative infinity for the left and a positive infinity for the right. Since it's both negative and positive, it's encompassing all of the y values. Okay, so here's some rules for domain and range. When you have an odd degree, so when you have a linear or a cubic or a quintic, if you have an odd degree, the domain and the range will always be all real numbers for both. Okay, that's because the ends go in opposite directions, so your x and your y end behaviors for each are going to be opposites, just like in this example. Okay, so you're going to have 1x is going to be going towards negative, 1x is going to be going towards positive infinity. Same thing for your y's. So they're always just going to be all real numbers. For the even degrees, like our quadratics or our quartics, the domain is all real numbers. Okay, same thing when we did quadratics. Domain is all real numbers. Now the range with quadratics depends on the max and the min. Same thing with quartics or anything higher. Okay, if a is positive, so if it opens up like this or like this, okay, the range is going to be y is greater than or equal to the minimum y value of one of the turning points. So if it's a quadratic, it's your minimum. If you have a quartic, they might not be even, so they might be something like this. You always want to take your lowest minimum. If a is negative, it's going to be the maximum. So y is less than or equal to the max y value of your turning point. So when you have a quadratic, here's your maximum turning point, and then it would be the y is less than. If you have something like this, that's a quartic, you want your highest y value. So with this example, I'm going to use factoring. I'm going to take out my GCF from here. So x squared comes out. I have an x squared minus 2x minus 8. Okay, now I have a quadratic left. So I'm going to factor what multiplies to negative 8 and adds to negative 2. I'm going to have a negative 4 and a positive 2. So when I set this to 0, these will be x equals 4 and x equals negative 2. When I have x squared, I'm going to set it to 0, and then I'm going to take the square root. When you take the square root, you get plus or minus 0. But since negative 0 is the same thing as positive 0, this is going to be x equals 0 of multiplicity 2. So we have 4 answers here. Okay, and then this is our graph. So you can see that when you have a multiplicity, it looks like a parabola. So here we have a parabola shape. When you don't have a multiplicity, it's just like a linear shape. It just goes right through like a line. Okay, so now we're going to put all this stuff together. So we're going to use a calculator to find all the zeros. Then we're going to use synthetic division to find the other zeros. Then we'll use the calculator to find the turning points. And we will graph it, sketch the graph, identify all of our behaviors and intervals and domain and range. So I'm just going to rewrite this. So p of x equals 3x cubed minus 5x squared minus 11x minus 3. So if we put that in the calculator, I'm going to use 3 from the calculator. Okay, so you can use whichever one you want to use. Now there's more than one way to do this, so I'm just going to use 3. So if you graph this, you'll see it crosses at 3. So I'm going to use 3 for synthetic division. So I'm going to put a 3, a negative 5, a negative 11, negative 3. So that 3 comes down, I multiply it, I get 9. I add it, I get 4, I multiply it, I get 12. I add it, I get 1, I multiply it, I get 3. Add it, remainder of 0. So then I have 3x squared plus 4x plus 1 equals 0. So now I can factor this. AC is 3 and B is 4. So two numbers that multiply to 3 and add to 4. We're going to use 3 and 1. So 3x squared comes down, 1 comes down. Rewrite 4x using our two factors. So 3x and 1x. I can group these now. I'm going to take out my GCF here, which is 3x. I'm left with x plus 1. I can then take out a GCF of 1 here, and I'm left with x plus 1. So I have 3x plus 1 and x plus 1 equals 0. So when we go to solve this, x equals negative 1/3 is one answer, and x equals negative 1 is another one. Also, x equals 3 from the calculator. Okay, so I'm going to start keeping track of my information. So the y-intercept is 0, c, or 0, my constant term. So since it's negative 3, 0, negative 3 is my y-intercept. My x-intercepts, since I just solved for them, I know I have x equals 3, x equals negative 1/3, and x equals negative 1. So I'm going to have 3, 0, negative 1/3, 0, and negative 1, 0. And then I have to find my turning points. So we're going to plug that into the calculator and find the maxes and the mins. Okay, so I'm going to round to 2 decimal places. Okay, so that's going to be my maximum, and then this is my minimum. Once I have this information, I can go ahead and graph. So all right, so I have 0, negative 3. I have 3, 0, negative 1/3, 0, negative 1, 0. So negative 0.68 and 1 point. Oops, like here, I'm going to label that because that's my turning point. 0.68. Oops. Sorry. So negative 0.68, 1.22. Then I have 1.79, and I'm just going to put this down here since I'm running out of space. 1.79, negative 21.50. So now I can fill in the shape of this. So it's going to go up, down, oops, up. Okay, from here we can do our end behavior. So x is going to go towards negative infinity, y goes to negative infinity. Here x is positive infinity, y is also positive infinity. Okay, it's increasing from box all of the x's that we need to use, from negative infinity to negative 0.68. Then it decreases from negative 0.68 to 1.79. And then it increases again from 1.79 to infinity. So here we have those. And then our domain and range. So since this is an odd degree, my domain is going to be all real numbers. And my range is also going to be all real numbers. So now I answered, I believe, all of our questions and behavior intervals, domain and range. Check.